7.5, roots and zeros. And hopefully you realize that roots and zeros are the same thing. Not sure why they call this section that, but let's go through that list again. Roots, zeros, solutions, they're all the same thing. They're all x-intercepts. We almost make a song out of that. Maybe we can put that on here too. I'm going to go through a few kind of basic ideas. Let's talk about factoring real quick. And a lot of y'all are still having trouble with factoring. It is, for better or worse, one of those skills you'll have to master if you're going to pass this class. But the idea of factoring, the main idea, you take a number, you break it into smaller pieces, and if you were to multiply those pieces together, you would get what you started with. So that, of course, is 6th grade level factoring. Then, of course, in this class, maybe you touched on Algebra 1, you get a polynomial. Well, we can use a few different methods, but we end up with x minus 3x plus 2. And if I multiply those together, then I get back to what I started with. That's the idea. You take a bigger number, you break it into smaller pieces you can work with. Okay. Now, the way you're going to use that today is you're going to start with a really big number that you probably don't know factors for. Okay. None of you probably know factors of anything going to 285 off the top of your head, or at least you don't know, two numbers off your times tables anyway. But hopefully what you do know is that we can figure out one number that goes into it. It ends in 5, so you can divide it by 5. All right, so let's see what happens. Well, that would give me 5 times 57. Okay, 57 is one of those numbers you probably don't know two numbers on the times table for either. But it's actually not prime. And if you know some more divisibility rules, if you add 5 and 7 together, you get 12. That means you know you can divide it by 3. And 3 times 19 is 57. 19 is prime. We've got this thing down to prime numbers now. So in other words, if I took those 3 factors and multiplied them together, I would get 285. Okay? So that's kind of what you were doing in the last lesson, 7.4. You're taking a polynomial or a number, you're breaking it down by factors you know and getting it down to other factors by using different methods. And today you're going to have to use a lot of different methods to factor and solve. So it's kind of a revisitation of Chapter 5 and Chapter 6 and what we've done already in Chapter 7. It's kind of a recap of everything. One thing I do want to make sure we're really clear on is the relationship of factors to zeros. So factors and zeros are basically the exact opposite of each other. You can use the factors to get zeros. You can get the zeros to find the factors. So let's just say that x plus 2 and x minus 9 were my 2 factors for whatever I'm talking about, some polynomial. Well, what that translates to is that x minus 2 and x equals negative 2 and x equals 9 are my zeros. All right, so if a polynomial had those 2 factors, these are the 2 zeros it would have, negative 2 and positive 9. Okay, it's like they're opposites because you set the factor equal to 0, and that gives you the solution, the negative 2. Okay, you can take a 0 or solution and you can move the number to the other side with x, and now you're back to a factor. So you really need to understand how these go back and forth from each other, just like addition and subtraction are opposites, multiplying and dividing are opposites. Factors and zeros are opposites. Okay, so that's a distinction you really need to understand at this point. All right, that's the preliminary stuff. So let's give the actual lesson a shot. First example. Find all the zeros for f of x equals x plus, let me start over. F of x equals x cubed plus 6x squared plus 21x plus 26. Okay, now I doubt you know how to factor that off the top of your head. There are some rules in the book you can do it without a calculator, but I'm going to let y'all go ahead and cheat. So take out your calculator and let's type this in. We get x cubed plus 6x squared plus 21x plus 26. Okay? And we're supposed to find all the zeros for it. So let's hit graph and see what we can find. Okay, it looks like maybe negative 2. And that's about it. Okay, now you're welcome to zoom out and search the universe looking for these, but looks like negative 2 is probably going to be it. Let's recap how we find solution zeros or roots. You want to put y2 equal to 0. That is the x-axis. If y equals 0, you're talking about a horizontal line going through the y-axis at 0. That is the definition of the x-axis. Okay. So you want to second and trace. You want to do number 5, intersect. And if x doesn't show up on your screen, you need to get it where you can see it. So let's see. We've got 0, 26 right now on mine. That means, well, 0, 26 will be up here off the screen. So I need to come back to the left until x shows up. So you can kind of watch what it's doing. X at -1 now. There it goes. All right, it showed back up. All right, remember, we're doing second trace intersect. We just want to know where it crosses the x-axis. Get it close, enter 3 times, and it should give us an answer. All right, it was -2, 0. You want to be sure, because I will give you decimals, I will give you fractions for your initial 0. You want to be sure you know where it is. All right, so over here in this list, I'm going to say x equals -2. All right, now, how many zeros should we have? Well, degree is 3, so I should have room for 3 of these. I'm going to go ahead and get it set up for that. All right, I better get 3 zeros. If I don't, I'm not doing something right. All right, so this is exactly what you were doing in the previous lesson. You have one of your zeros. That's what goes in the box. You're going to do synthetic division, basically factor this down, and then we're going to solve by factoring. That was a skill you did a lot of in Chapter 6. So -2 goes in the box. I know that because -2 is the 0 here. I also know that x plus 2 is a factor if somebody had asked me that. That may be a question I ask you on the test. I may tell you to tell me all the factors by looking at a graph. Okay, you should be able to do that. So let's say the coefficient here is 1, 6, 21, and 26. Bring it down. So bring down the 1 times -2 is -2, add them is 4, multiply -8, add those should be, I don't know why I'm struggling with that, 13, and -26. All right. So we start with x cubed. This should be 1x squared plus 4x plus 13. You're welcome to attempt to factor that, but 13 is a prime number, and the only thing that can ever go into or multiply to make 13 is 13 and 1. And there's no way that's adding up to 4. All right. So bells should be going off in your head now. That's going to be a quadratic formula. All right. Now, if you need to go back and review quadratic formula, it was also in Chapter 6. I'm going to dive right in. I'm going to assume you know how to do quadratic formula. Go back and watch the video on it if you're not sure. All right. So -b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so we might run out of paper. We'll see how this goes. It's going to be a tedious process. -4 plus or minus the square root of 16. Let's just put the minus in here and then just treat these however they come out. So 4 times 1 is 4 times 13 is going to be 52. Trick to remember that there's 13 cards in each suit in a deck. There's four suits, 52 cards in a deck. So just a little trick, 4 times 13, that comes up a lot. 2 times 1, okay, so 2 on the bottom. All right, it's tempting to cross that out, but you can't do it till we get this resolved. So -4 plus or minus the square root. 16 minus 52, I might have to cheat off to the side here real quick. -36. It's okay to use a calculator to save time. Just don't let it do all the thinking for you. -4 plus or minus the square root of 36. All right, 6i. Should know that one by now. All that's over 2. All right, now that the radical's gone, now we can think about reducing. 4, 6 all have something in common with 2. That would be 2. That's what you can divide them both by. So divide them both by 2. And it's -2 plus or minus 3i. Okay, it got kind of scrunched. So up here where my zeros are, well, -2 plus 3i is one of them. -2 minus 3i would be the other. That's what the plus or minus is for. And just to check, make sure we're done. Let's see, we were supposed to have 3 zeros because of degree 3. We've got 3 zeros, so we are set. So let's try one more. If you need to revisit that one, go back and watch it. Again, you've got to do quadratic formula. You've got to solve by factoring. You've got to be good with all these techniques. If you need to go back and watch some of those videos, that seems like more time, but it may be what you have to do. All right, example 2. This one's a little bit bigger. We got a degree of 5, so we're going to have 5 zeros to find here. It's x to the 5th minus 5x to the 4th minus 3x cubed plus 43x squared minus 110x minus 150. Yeah, that's pretty big. We do know we got 5 zeros, so that's a good place to start. Let's go ahead and put it in a calculator. So x to the 5th minus 5x to the 4th minus 3x cubed plus 43x squared minus 110x minus 150. I'm going to take a quick second here to recap, make sure that I put everything in right. I really encourage y'all to do that because I get those questions all the time. What did I do, Mr. Harden? And you put a 5 instead of a 7 or something like that. Go back and check your work, make sure you typed it in right. So let's graph it. Let's see what we get. This one's not showing up real nice. One thing you could do here is play around with your window, see if you can make it fit a little better. Because these are so steep, you may want to do that. I think I am. I'm just going to change the y values because it's fitting left and right. It's just up and down. It's really going off the screen. So I meant to keep that -10. I'm going to go down and change the y minimum to say -25. Change the maximum to 25. Complete guess. I don't know if that's going to help or not. Let's just see. All right, so we've kind of squashed this thing down a little bit. This thing is still ridiculously steep. So because it's so steep, I'm going to go extreme. Let's go -250. Let's go +250. Let's just see if that helps. Yeah, there we go. That's a little better. Okay. Now, one of these is going off the screen down here, and I really don't care because what I care about is where it crosses the x-axis. And I can see 3 of them. So what that's telling me, there's 5 total zeros. I can see 3 of them. That means they're real. If I can't see them, the other 2 must be imaginary. That's where we are. So let's find the ones we've got. Second trace, intersect. Just get your x really close to where they are. Same process as before. See, when it's real steep, it moves fast, so that's why I wanted to zoom out. All right, so I've got one at -3. I'm going to go ahead and just start an answer chart here. We got one at -3. We've got another one at, I'll just go ahead and save some time. Since you're watching the video, you can do second trace. That one's at -1. This one is definitely at 5. When you're doing your homework, you definitely want to work these out and be sure. I made this one up backwards. I know those are the 3 zeros I'm supposed to start with, so I'm going to go ahead and use those as they are. Okay. Now I should get two more zeros, and they will be imaginary. Okay, I know that because I've got 3 real. There's supposed to be 5 total, so we'll have to work it down and find them. Same process as before. We need to do synthetic division. You're going to have to do synthetic division 3 times. So here we go. Let's just dive in. -3 goes in the box. That's the first solution I had. All right. 1, -5, -3, 43, -110, -150. All right. No shame in using a calculator on these if you need to. Just do what you need to do to get the right answer. So bring down the 1, -3, add them, -8. Multiply, get 24. That's 21. That's going to be -63. And I'm going to double check, make sure. Just to be sure. Yeah, that's right. This one's -20. That's going to be +60. So -50 and +150. That's 0. All right. So now we're down to 1x to the 4th minus 8x cubed plus 21x squared minus 20x minus 50. But I really don't care about putting the x's in here because I've got to divide out the other 0. So I'm going to immediately drop down all these coefficients, put the next 0 in the box, and divide again. Okay, so 1, multiply, add, -9, multiply, add, get 30. That's going to be -30, so -50, so +50, no remainder there. All right. Whoops. Hope that was not too far off the screen for you. And now we've got one last 0. Let me scooch back up here so you can see it. The last 0 was at 5. So now let's synthetically divide 5 out. Okay. So bring down the 1, multiply, you get 5, add, you get -4. That's going to be -20, it's going to be +10, multiply, add, there we go. All right, so I'm going to get some more paper so we can continue on with this problem. I'm just out of room on this page. So what we know now is that we have x squared minus 4x plus 10. Okay, that's from the synthetic division. We've divided synthetically 3 times. Now we are down to a trinomial. So best thing to do now is try to factor. So the question is, can you find factors of 10 that make -4? Well, there's 1 and 10, there's 2 and 5, and that's it. There's no other way to get 10. No matter how you play with the signs, that's just not going to work out where you get -4. This will be another quadratic formula. So -b plus or minus the square root of b squared minus 4 times a times c. I'm going to extend that bar over. This bar goes under everything. And it's 2a on the bottom. All right, so 4 plus or minus the square root of 16 minus 40 all over 2. So 4 plus or minus the square root of -24 all over 2. All right, at this point, there's a negative, so I know there's going to be an I outside the radical. 24 is not a perfect square, so something's going to be left inside. So somewhere, probably scrap piece of paper or somewhere else, break down 24. Let's get all of its factors. We get a couple 2's and 2 times 3 left over, or 6 left over. So 2 outside from those 2 and a 6 left over from those 2. And make sure you reduce. You can divide 4 by 2 and get 2. You can divide 2 by 2 and get 1. And the I squared of 6 stays the same. Okay, so those are my last 2 zeros. I found 3 pretty easy. I found them on the calculator. The last 2 we had to do a lot of work to get to them. Okay, but we do have 5 total now. This is 2. This is 2 plus I squared of 6, 2 minus I squared of 6. Okay. As you practice this, you'll get a lot faster. Don't get discouraged because this was a longer video. It's a long process, and it's a big test of everything you've done. So this will really highlight where you're having trouble. Just stick at it, dig up the old stuff you need to, make sure you can get it.